Sorry for the delay, overlapping Zoom meetings. Here we go. Oh, that was from my last Zoom meeting. Some good fun stuff in chemistry there. We are going to talk about some problems that were sent to me by a student by email, some really good questions, and we're going to go and do a bunch of them. Then we'll stop our sessions and share them, and then come back. This is going to happen over and over. She asked for W19 Test 1 Part 1. And her questions have yellow highlighters on them. So they're not for everything, but I've kind of summarized what we need to do before we can get to her question. If we are supposed to answer, she says there are 6 reactions here, what to use and what not. Okay, now she's going to ask that question a lot of times. I have the same answer every time, all right? If there's a list of reactions, you have to do every one of them. I know what happened when she was looking over this and then she was looking at the keys. Good students do that. They'll have the key there and she'll see, oh, dihydroparan doesn't show up in the product. Can I skip that one? And the answer is no, because dihydroparan, if you look back in our chapter 10 notes, is a protecting groups for alcohols. Later on, when we make a lithium, organolithium reagent, you cannot have an alcohol present. So this is a protection of the alcohol, dihydropyran and toluene. So steps, when we get down to here, when we're supposed to do the 6 steps, I'll be bringing that up again. But the first question was, we got to get to here. So without further ado, she really didn't want to know about questions 11, 12, 13. But here's a nice little summary of what happens. First 2 steps for making product 1, create this, the organolithium. The next 2, you can't skip any. 3 and 4 create this when it reacts with butanol. And then steps 1 and 2, we're going down here. Thionyl chloride followed by magnesium and ether, make a Grignard. And then step 3, isobutanol. And that's where I stopped because one of the questions later is what's the pKa for this reaction? All right, so after step 3, you're here to make product 3 here. And the acid you're using, I'm answering this question first, is a carboxylic acid. Please verify that acetic acid is this and that it's a carboxylic acid with a pKa of 5. And my pen's not on. And the product you're making here, product 3, has a pKa of 17 because it's an alcohol, and pKeq right above the highlighted question marks equals 5 for the reacting acid pKa minus 17 for the product acid pKa equals negative 12. So Keq is 10 to the positive 12. And that's what the question asks. 10 to the positive 12. And that one be way over here. And now we can get to the 6 steps, going from product 3 to product 4. So chromium 6 oxide in aqueous sulfuric acid will make our alcohol into a ketone. And for the purpose of not redrawing everything every time, we'll have R1 and we'll have R2. R2 is basically an isopropyl. That's not a problem. So step 1, makes, what am I doing here? Wait a minute. Did we get to product? This is product 3? This is not product 3. We only did 4 steps. I got ahead of myself, ladies and gentlemen. The acid base step on the way to product 3. Did I do that right? Product 1. Where's product 2? Acetic acid. Product. Oh, yeah, I'm here at product 2. Way ahead of myself. My apologies, everybody. We're at product 2. So what happens in product 2 when we go to product 3? Dihydropyran and toluene, and then N-bromosuccinimide. I'm going to do that, and my R is going to be a problem. And part of the problem is my phenyl went a little stray here. All right, so step 1 is putting the DHP protecting group on, and step 2 is going to be putting a benzylic bromine. N-bromosuccinimide will find either an allylic position or a benzylic, which is one away from a phenyl, and put a bromine there. So I'm going to protect my O and put a bromine on the benzylic position. Phenyl now has a bromine on the benzylic position, and going down, down, up, down, up. And the O coming off here is going to be protected with DHP. And then when you're protected with DHP, you are now an acetal. Acetal right there. That's the acetal carbon. And notice the O does not have an H, so it cannot have acid-base issues anymore. Next up, lithium in hexane, followed by copper iodide will convert. First, lithium and hexane will make an organolithium right here, lithium. 4 makes a Gilman. So let's combine 3 and 4. And this time I'm going to use the old big R group. Big, big, big. I don't need to do that. Control Z didn't work. Here we go. Everything below, call it R3. So we'll do steps 3 and 4. We're going to have phenyl on one side, phenyl on one side, and we're going to have a copper, 3 and 4 copper lithium when we're done. And yep, there's going to be 2 of them. I'm going to have to show that too. And then R3's here. And there's 2 of these here. And that's what a Gilman looks like. 2 of these groups attached to the copper. And then we're going to do a coupling reaction with ethyl iodide. And what happens in step 6 is called deprotection, also known as hydrolysis. That's to get rid of our protecting group. So we're going to sneak product 3 down here. Ethyl iodide means this bond to copper will now become this bond to an ethyl group. And our OH will come back, and we don't care what happens to the protecting part. It'll be OH just like it was before. So product 3 finally after steps 5 and 6. Drawn out in its entirety. Phenyl. I just noticed we gained a carbon. I didn't like that. Trying to erase stuff. Phenyl is attached to a carbon that now has an ethyl group on it. It coupled. And R3 is not R3 anymore. You better draw it out. Comes down to a carbon that goes over to a carbon, comes up to a propyl. Down to a carbon that's an O, and it got its H back during the hydrolysis step. Off this carbon is also an isopropyl. So there's product 3. Yep, all 6 steps. And you'd have to find the correct matching name. 2-methyl 5-phenyl, 2-methyl 3-ol, 4-ol. I got a 3-ol here. Did I do something wrong? I don't know. Based on over here, 1, 2, 3. So I don't know. That might be her circle. 2, 3, 4, 5, 6, 7, 8. So I've got a 6-phenyl. Maybe there isn't one of the products with the right name there. That is product 3 as far as I know. I can get back to you later if it's not the right product 3. But the idea that needed to be addressed was you have to use every step I give you here. And yeah, this is an advanced question, so I wouldn't expect a lot of people to get this one right. And moving on, she wanted to know about mechanism for this one here. We got some old stuff in here. Acid base step to set up what we previously called an NGP reaction. Why NGP? Because I have a nucleophile in the molecule, and I also have a leaving group in the molecule. And we do a backside attack. We make an epoxide. Epoxides are good, even though she didn't ask for this. It's not a hard mechanism. We'll sneak it in.
Dr. Whitaker?
Yeah.
Where did the chlorine come from in the first molecule you drew?
Oh, the vicinal halo hydrin formation you want to review in chapter 6. First thing that happens in that mechanism is they do this and you generate a chloronium. And that goes up there, and then that gets attacked. That leaves, the lone pair comes back with an etc. going on. 6.1 E or E question mark, vicinal halo hydrins. And it's in the key. And over here, almost finished on this one. This grabs the H here, neutralizing, making that. So yeah, one of our methods of making epoxides is to first do a vicinal halo hydrin formation, followed by an NGP type mechanism to get to here. And then we love opening those with nucleophiles. Very common in this class. And I think we'll do our first little break right there. That'll be a nice video. And we're going to come back in 5 minutes.